Good evening, everyone. This is the simulation presentation of Group 2. And today we simulate the electrical resistance on how to apply Ohm's law to simple circuit.
Using the lab pad is an important way to get the most out of this simulation. Is this the Grab the backpack and head outside to meet the rest of the scientists. What's this? They're not here anymore and the snowmobile is not here either. They forgot about us. Let's go back inside and use the radio to try and contact them. Click on the radio to contact the other scientists. Oh dear, something has gone wrong with the radio. Here, let me inspect it. Oh no, one of the resistors in the radio is broken. We need to fix it to be able to use the radio again. To be able to fix the radio, we first need to understand what electrical resistance, conductivity and resistors are. The electrical resistance quantifies how strongly a material resists the flow of electrons, while conductivity is the inverse property, measuring how well a material conducts the electric current. A resistor is the electric component used in electricity to increase the resistance of a circuit. We need the resistors to modulate the electric current for our circuit. We don't have the needed resistors to repair the radio, but different materials can function as resistors. We have plenty of pencils in the lab, and the lead inside is made of graphite. Graphite is a material that can be used as resistor. The resistance of a material changes according to the formula on the screen. If we are going to use graphite, we need to know how different sizes of pencil lead will affect the resistance. How will resistance change if we duplicate both the length and the cross-sectional area of a resistor?
Ano ba? A, resistance will remain the same.
Letter A
Kayo, pre.
is siguro.
A, no?
Exactly. According to the formula, cross-sectional area and length of the resistor have the same weight, so the resistance will remain constant. The resistance also depends on the resistivity of the material. Think about it, rubber and copper don't conduct electricity equally, right? This is because their resistivity is very different. Now let's try to put this knowledge to practice. That thing you see in front of you is a multimeter, and right now it is set up to measure resistance. The unit used to measure resistance is called ohm and it is represented with the Greek letter omega. There are measure the resistance of the two short rods. Why is the resistance of one of the pencils higher than the other?
Ano to? Different materials?
Letter A
Or
siguro. The material is different. Kasi magkaiba eh.
Kaya nga eh. Kayo, pre.
Hindi na comment.
Sige, A tayo.
Exactly. Both pencils have the same length and width. That means that the material must be different. Different brands of pencils contain different concentrations of clay that can significantly modify conductivity. Now measure the long and short rods made of material 1. There we go. Those two rods are made of the same material and have the same width. However, the longer one has a higher resistance. This is because the current have to move through the entire rod, increasing the chance that they will collide with the electrons in the material of the resistor. Now let's measure the two long graphite rods. Here you can see how the thinner pencil has a higher resistivity. Cool, right? To better understand this, imagine a road on which there are 200 cars. The longer the road, the more time it will take for you to get to the end. However, if instead of one lane there are 10 lanes, the cars will split among all lanes and you will get there faster. Something similar happens to electrons. If the resistor is wider, it is easier for the electrons to move without hitting anything on the way. Let's see how temperature affects the resistor. Place the highlighted graphite rod on the multimeter and I will heat it up. Then, look at the multimeter screen. Increasing the temperature of a resistor makes electrons in the resistor start bouncing faster. Faster bouncing increases the probability of electrons bumping into each other, making more difficult for the current to flow. Cooling down some materials makes them superconductors, having almost zero resistance to the current. Why does this happen?
Ano ba? Ah, bouncing or not?
Letter A siguro, tol. Agree ako sa'yo.
Bouncing. Sige, try natin.
Bouncing, man.
No, this is
Oh.
incorrect. Please try again. Check out the theory tab on your lab pad if you don't know the answer.
Letter C, tol. The electrons in the
Sige,
resistor.
sige. Try natin.
Right on. If the temperature is cold enough, the electrons in the resistor will not bounce, and this will significantly reduce the chance of the electrons bumping into each other, making it easier for the current to flow. Seems like you have mastered the basic parameters of a resistor. Let's learn how can we identify the resistance of the resistor that we need to repair our radio. Move to the test circuit table. This table is like a big simulator for circuits. Even though we don't have resistors in the lab, we can simulate them on our circuits table. Okay, here we have a very simple circuit with one battery and one resistor. Place the resistor and the battery in the circuit. Awesome! You can see that the symbol of each component has appeared on the screen, and you can see some extra information about them. Additionally, if you hover over the battery you will be able to see what is the voltage in volts of the battery. However, we still don't know what the resistance of the resistor is. To calculate the resistance of a resistor, we can use Ohm's law. You can see Ohm's law on the floating screen in the middle of the lab. In Ohm's law, the current is directly proportional to the voltage and inversely proportional to the resistance. It is very important to use the International System Units. According to Ohm's law, what would be the resistance of that one resistor in the circuit?
90? 90 ohms?
90 omega. 90 ohms. Ata.
Kayo, yung iba. Ano sagot niyo? ohms ka na.
Exactly, since the current is 0.1 amperes and the voltage... Okay, seems like you know how to apply Ohm's law to a circuit. Why don't we try to apply Ohm's law to our radio circuit and see if we can figure out the resistance of the resistor that broke? Move to the radio circuit table. We have the whole radio circuit on the left. I have amplified the area with the broken resistor, and we will treat the rest of the radio circuit as one resistor to simplify the calculations. Remember that you can hover over the different components to see the information that you need, and you can also see it on the big screen. You also have Ohm's law on the floating screen in case you forget it. Place the battery and the resistor on the plates. What is the value of the resistance for the resistor in the circuit according to Ohm's law?
Yung may meter ba or wala? 30 meter ohms or 30 ohms lang?
30 ohms lang
30 lang
ata.
yun, te.
Sige.
Letter C.
Yes, you are definitely mastering Ohm's law.
Nice
Now we know
one.
that we need a 30 ohms resistor to make our radio work again. Move to the test circuit table to learn about series resistors. Here we have 3 plates where we can place 2 resistors and 1 battery. Why don't you place all the elements? Place the battery on the plate closest to you and the resistors on the 2 connected in series. Okay, we have the circuit set up. Why don't we try and measure the current in our components? Pick up the portable multimeter and click on one of the resistors to measure the current through it. Seems like the current going through this resistor is 100 milliamperes. Click on the other resistor to check the current passing through it. It's also 100 milliamperes. As you can see, the current is the same in all the points of the circuit. A good analogy is to think of the current as the number of electrons. The electrons don't disappear, the number of electrons is always the same. Let's try and measure voltage now. I just switched the multimeter and now it is showing voltage. With the multimeter in your hand, click on the battery to check the voltage. Seems like the voltage across the battery is 9 volts. Let's check the voltage across one of the resistors. Check the voltage in the resistor closest to you. Okay, so seems like the voltage in this resistor is 2 volts. The voltage, current and resistance of each component in a circuit is based on the laws of conservation of energy and conservation of charge. They state that the total charge and the total energy are constant in any circuit. According to the law of conservation of the energy, if the battery provides 9 volts and 2 volts are used in one of the resistors, how many volts will be used in the other resistor?
7 or 5?
7 ata, tol. Kasi ma-minusin.
Ma-minus na?
Exactly. The energy must be preserved within the circuit. If the potential difference of the battery is 9 volts, the total voltage of the components must also be 9 volts. So, now we have all the information that we need to calculate the value of the resistance in each resistor. You have all the information in the tooltips and on the screen in front of you. Put down the portable multimeter. Fill out the information missing on the 2D screen.
Ano dito sa pinakababa? 80? 80 ba or 90?
20 ata. Isa I. 1.
Sa I1, okay. Tapos ang R1
Hindi,
eh,
100. 100.
100 dun sa I.
I. 100.
sa I1.
Yan, 100.
100 ata.
Tas yung R1,
R1, 20 yata.
20.
Kasi 2 volts eh.
Mm.
Tapos sa V2, 7. Kasi yung kanina 7 yung ano eh. 7
Click
volts
on the
yung
lab
nakalagay,
pad
di
for
ba?
more
Sa
information.
V2, 7.
B2. B2, 7.
Tapos 70
Then yung 70,
sa
ang
ohms.
R2.
Okay, sa ohms.
Yung
Thanks.
That's
I2,
100 ata.
100. Let's see.
Very good job. Now one last
Nice.
thing. We need to calculate the equivalent resistor. An equivalent resistor is the resistor that will have the same effect on the circuit as the combination of resistors. For resistors connected in series, the equivalent resistor is just the sum of the individual resistors. What would be the equivalent resistor for R1 and R2?
Ano ba? 90? 90 ba? Wait. 90 or 70?
90 ohms ata.
So 70 ako, pre.
Sa akin, 90.
So, try naman natin yung 90.
Precisely. Seems like you have understood the series circuits. Now let's try to add it to our radio circuit. Move to the radio circuit table. I have added the radio circuit on the left. You just need to place the rest of the components. Place the battery on the plate closest to you and the resistors on the other two plates. Now you have all the needed information to calculate the rest of the variables. Remember that you can check all the information in the tooltips or on the screen in front of you. Fill in the missing information on the screen.
So, simulan natin sa R3. Ano bang R3 natin?
6 ata. 6 volts. The R3. 60. Kasi 6 eh. It is 60. R3. Tapos sa 60 lang. 60 sumobra. Yung R3 60. Tapos 1,000 I3.
Click on the lab pad for more information.
I3 1000.
Ay, 100.
100.
Sorry. Hindi pala ako open mic kanina. Tapos yung R1 sa V220 kasi 2 volts eh.
Okay.
Tapos 100. Yung
Ito, yung I1.
I1.
100, okay.
Siguro sa V2, 110 and 100 kasi ganun yung pattern eh. Isang digit, dalawa, tas tatlo.
Oh,
7,
okay.
70, 100.
1 lang.
1. Okay. 1.
Tas R2.
110 tapos 100.
Oo. Kasi ayun yung pattern eh. 2 digits, 3. 1, 2, 3 digits. Yan. Try natin.
6100 na.
Good job. Yes, that is
Nice.
what our radio looks like. Now we need to calculate the equivalent resistor. Are you ready for it? Given that R1 and R2 are connected in series, which is the equivalent resistor of these two?
Mm.
30
20.
ohms.
30.
Sure ako 30. Sure na ako dyan.
Yes, the sum of R1 and R2 is 30 ohms and will modulate the current to provide the radio circuit with the same current and voltage as both individual resistors. What happened with voltage and current in the different resistors of a circuit with resistors connected in series?
Siguro ano, current is the same. Yung I.
I is the same,
Oo. Oo,
but
yun, current.
volts is field.
Yes, yes, and 1,000 times yes. Seems like you have mastered the resistors connected in series. Let's see how you handle resistors connected in parallel.
Parallel.
Move to the test circuit table. Here we are going to use the same resistors as in the series circuit, but we will connect them in parallel instead. For parallel resistors, it works in the opposite way to series resistors. That is, the voltage is the same across both components but the current splits. Let's set up our circuit. Place the battery on the plate closest to you and the resistors in both plates connected in parallel.
Saan daw yung battery? Dito.
Closest daw. Kasi yan yung malayo.
Hmm.
Good job! We can use the same analogy that we used before. The current will split because there is a finite number of electrons, so some electrons will go towards R1 and some others will go towards R2. Voltage is the amount of energy that we provide to a group of electrons, so the amount of energy per group of electrons is the same, and each resistor receives 9 volts. According to Ohm's law, will current split equally between R1 and R2?
Ano ba?
Sibre.
Because they are the only two ways for the electricity.
A answer ko, no, because their resistance is different. Try muna natin.
Sige.
There you go. The current will be split. But since Ohm's law determines that the current depends on the voltage and the resistance, the different resistance in R1 and R2 will cause a different current across each resistor. Seems like you've got it. Let's solve the rest of the variables for this circuit. Fill in the rest of the missing variables on the screen.
Where's the screen? Dito. Yung V2 natin kanina, no, 1. Tapos dito yung 100. Ay, hindi. Ano to? I2?
Zero, 1 di ba? 1? Di ba?
Oo, 1. 1 lang. Wala eh.
V2?
1.05.
9 ata, 9 kasi 9 volts.
9. Okay.
Tapos 0.9. Kasi pag dinivide mo ata yun.
Oo,
tama.
divide sa
9
ano,
diba?
no?
Oo. 9 divided by 10
Click
divided
on the
by
lab
9.
pad
Tas
for
sa
more
V1,
information.
9 din. Kasi given 9 volts eh. Ayun sa baba. Tas ano?
Tapos divide din to, no?
0.45.
0.45.
Tapos yung sa 9? Ay, 1.35? Kasi pag a-addin, 0.9 plus 0.45.
0.45.
Sagot 1.35. 1.35.
Yes, way to go. As you can see, there is more current passing through the resistors with lowest resistance. Makes sense, right? The electrons will preferably go the way that offers the least resistance. Let's do one last thing before we move on. We need to calculate the equivalent resistor. For parallel resistors, it is a bit more complicated. Look at the floating screen and you will see the formula there. What is the equivalent resistor for R1 and R2 connected in parallel? Note that you can use the calculator located on the top right corner of your lab pad.
Saan yung formula? Ito?
6.66 ata sagot. 6.66
Amen,
ohms.
A.
Letter A.
Sige. A.
That's right. Can you see that the equivalent resistor has smaller resistance than any of the other two resistors? Seems like you understood how resistors connected in parallel work. Let's try to add the radio circuit to our previous circuit. Move to the radio circuit table. Here I have added the radio circuit to the table, and we have on the table the same resistors and battery that we had before. Place the battery on the plate to the right and the two resistors on the two plates connected in parallel. All set up. Now fill in all the missing information on the screen in front of you.
Ang V3 natin, 6? 6 ba? Or
9 ata kasi 9 volts eh. Ayun na yung VO.
ito. Okay,
Ayan,
okay.
pagbabasa. 9 lahat ng volts.
light ng volts na
Kasi ayun yung ano eh. Tapos i-divide. 9 divided by
60.
15. 0.15.
Try ko i-calculate lang.
Nasa ano, tol? Sa lab pad, try mo. Sa lab pad.
Sarap.
Click mo yung lab pad.
Pad.
Yan.
Ito na. Tapos ano isa?
60 divided by 9.
Click on the lab pad for
9.
more information.
60 divided by 9.
60 divided by 9. Wait. Balik ka data.
9 divided by 60 pala. Yan,
tama.
balik na yan. 0.15.
Tas 9 divided by
10. Baliktad pala, my bad.
0.9.
Ano? 9 divided by 20.
20. 0.45.
Tapos pag-a-addin natin lahat.
0.15 plus 0.9 plus 0.45 1.5.
Amazing. You have really mastered the parallel resistors. We are so close to having what we need to fix the radio. One last thing. What would be the equivalent resistor for R1 and R2?
S- 6.66 ulit.
6.
Para kanina.
Exactly. The equivalent resistor in this case will be the same as we calculated previously, since we are combining the same resistors. You have already learned about both resistors connected in series and in parallel. We need to reduce the voltage of the current reaching the radio circuit. Which type of wiring would you choose?
Ano to? Resistors connected in series to, no?
Amen.
Resistors connected in series. Kasi series A daw. Sabi ni Jairo. Sabi nila. Hindi yan lang, majority na
That's
lang.
right. Resistors connected in series are the way to go. Remember that voltage is the same across all components connected in parallel, so the radio will receive 9 volts instead of the 6 volts it needs, and it could potentially break. Okay, seems like you know everything that you need to know about resistors to fix the radio. Let's get hands-on. Move to the test circuit table. Here you have everything you need to build your own 30 ohm series resistors to fix the radio. We only have pencil leads with resistances of 7, 12 and 22 ohms, and as you can see none of those combined are 30 ohms. But don't worry, you can cut any of the graphite bars in half. What will happen to the resistance of the graphite rod if we cut it in half?
Ano to? Reduce in half to, no?
Reduce
Kasi
ka. Kasi
hinati,
hinati eh. Common sense naman siguro, no?
Exactly. You remember it. Reducing the length of the resistor will proportionally reduce the resistance. You need to create your own series circuit that corresponds to an equivalent series resistor of 30 ohms. You can use the machine on your left to cut the graphite bars in half. You can only use a maximum of 5 resistors in series, and you will be able to see the total resistance you have created on that screen in the middle. If you made a mistake, you can always discard the lead in the trash bin. Create a 30 ohms resistor, connect the battery and press the switch to see if it works. Seems like there is something wrong here. Are you sure that the total resistance is 30 ohms and that the battery is connected?
Oh.
Lagay mo yung nasa gitna. Sa gitna.
Ito.
Hindi, yung
12.
22.
Yung 22. Dito, no?
Yes.
Try natin.
Tapos yung ano,
Yung 7, siguro sa dulo na lang.
hindi.
Oh.
Kailangan maging saktong 30 eh. Diba? Yung 12, yung pinakamalaki. 12.
Ito lang.
Tapos mo
Malapag.
to, tol, sa kulay pula. Yung sa toxic na sign.
Dito. Okay.
Yan. Sa DN.
Tapos ito yung hatiin natin, no?
12. 12 yun, diba?
12, bali 6 na lang siya.
Hindi pa rin sakto eh. Kailangan maging saktong 30. 28.
So ito 22.
Alam ko na. Yung 22 hatiin mo. Tanggalin mo yung 22.
Gawin na lang natin siyang
11.
11.
Yan. Hatiin mo. 11, 12, tas 7. Para saktong 30. Tapos lagay mo.
12.
Tapos yung 7. Yan. Tapos try mo.
It's working. Let's contact the rest of the scientists and hope that they're not too far away.
Continue.
Hello, can you guys hear me?
Yes, we can hear you, Dr. Wan.
You forgot one of the scientists in the lab. Could you come back?
Oh, sorry. You are right, we are on our way. We are not far, just go outside the lab, we will pick you up there.
You heard them. Click on your backpack to go outside and...
I am so sorry that we forgot about you. Luckily you learned how to repair the radio and contact us. Good job.
Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.
That's the presentation of Group 2. Thank you.
Thank you po. Goodbye and thank you po.
Bye po.